Ashwin is trying to figure out all the parts of the piecewise function graphed below. From the graph, which type of function defines the output when x equals -2? If there is more than one, select all that apply. So what type of function do we have in this piecewise function when x equals -2 right over here? Well, let's take a look at the overall function really quickly. We have three different parts to this piecewise function, and it's a continuous piecewise function as well because there are no gaps in y values. We've got 1, 2, 3 different parts. It looks like, for this first part over here, this looks like a simple linear function. This second part over here, we have a constant function, a horizontal line through y equals 1. And then over here, although at first glance it looked almost like a linear function to me, I'm now noticing that the growth is not the same, is not constant throughout the entire function, so we'll have to come back and figure out what that third type of function is. And if I look closely, I'm guessing it's either an exponential or a quadratic on this end part. Let's try like a pretty normally growing one, so let's try a couple. Let's try 2 to the x, or y equals x squared. And I can already see my 0.11 if I test that out. I've got a 0.11 over there. 2 to the 1 does not give me 1, so it can't be 2 to the x. But it looks like it could be a quadratic where y equals x squared. So it looks like I've got a constant function in here, a linear function in here, and then a quadratic function in here. Now let's look at what the question is asking for, which is at x equals -2. At x equals -2, we are part of the domain where the function is defined by a linear function. In this function, it also says select all that apply. In this function, are there any places where the function, the piecewise function, is defined by more than one type of function? Well, if you look at the meeting point of the linear and the constant function, it is not an open circle there. It is a closed continuous function. So at the meeting point -1 and 1, this piecewise function is defined both by the constant and the linear. Also, if you look at this other meeting point over here at +1, 1, there's no open circle. It's a continuous function. So that function is also defined, that part at 1, 1 is also defined by this constant function and the quadratic that it meets at that point. So those two meeting points of the different types of functions are the only locations where this piecewise is defined by more than one function. Otherwise, it is either defined by this linear function, this constant function, or this quadratic function.